Hey, good evening, everyone. Thank you again for spending your evening with us tonight at Immigrant Tech is Our Better. And tonight we have a wonderful guest here that will be talking about how to apply machine learning, how to actually demystify AI and bring it to the level of the ordinary person, really. Like if you can use a mouse, then you can leverage AI. But before we get into all that, I'm just going to quickly go over just some information about our group here. So I'm sharing my screen. And you think I would have mastered this by now. Can you see it? Can you see my screen yet? No. Right.
Not yet.
I have like a million windows open.
Yes,
Okay.
now it's loading. Yeah.
All right. Okay. So Immigrant Tech is Our Better. We're a casual meetup group. All we do is hang out and just talk about tech, careers and startups and the opportunities that are in there, you know, trying to get in the headspace of the fourth industrial revolution and get acquainted with the future of work and start to rethink how we usually define careers, especially for immigrant professionals. We tend to go very academic. We like all the degrees, and those are great, but we need to understand, like it's important to know how to key into the direction of the future of work. So here in this meetup group, we take tech concepts, we demystify it, we create this welcoming space for people who are exploring, because the idea of tech from a distance can feel intimidating if you're not close to it, if you've not tried your hands on some things. So we are a tech enthusiast group for highly skilled immigrants, for immigrants, even if you are not an immigrant. This group is not exclusive. We're just trying to create that space for people who are yet to build a support system, who are yet to build a network so that they can have that connection, but it's not exclusive. So if you're interested in tech careers, if you're interested in startups, this is the place where you can ask all the questions, and we bring in people from the community. So we represent a bridge into Alberta's innovation community, just so that people know where to go and to explore what is here, what's going on here, and to also shine the spotlight on Alberta tech ecosystem, because we have a lot going for us in Alberta outside oil and gas. So we want to tell that story. We want to attract immigrants to keep coming here, that Alberta has a lot to offer, whether it is in oil and gas or not. So yeah, and of course, this creates opportunities for networking, for mentorship. So many relationships have been formed through these groups. People have got jobs, people have got mentors and coaches just by connecting in here. And yeah, we curate tech content, events, just opportunities. And the goal is to provide community and support for immigrant professionals that are looking into the tech space. And with that, I will turn it over to Kwame, who's our guest for this evening. I'll just take it away. I'll let you take it away, Kwame, and introduce yourself and tell us all the magic.
Kwame, you're muted.
All right, thank you very much for having me, and thanks for the introduction. My name is Kwame, and I'm a co-founder at Braintoy. and we seek to make AI easy for everyone. We seek to build a technology that can make it easy for everyone to apply AI techniques in solving meaningful problems, production AI solutions. So I'm happy to be here to talk about AI, and I hope that I'll be able to demystify it for you. So first, I'll ask you a very simple question, which is, I know there are different people here, but is it easy or difficult to build AI solutions? Just answer it to yourself, easy or difficult. And we're all going to answer it together at the end of the talk. Now, I'm going to give you two options. And the first option is that I'm going to give you $10,000 a day for 30 days. So today I'll give you $10,000. Tomorrow you get 20, you get 10 and then it becomes 20. The next day it becomes 30. Then the second option is I'm going to give you 2 pennies that double in value also a day for 30 days. So today is 2 pennies, tomorrow is 4 pennies, the next day is 8 pennies, and so on. Which one will you choose? Now, if you've listened to some of my talks before, you might have seen this illustration before. I actually got it from Jeffrey Rogers from Singularity University. So which one did you choose? Now, if you choose the 10,000, then by the end of 30 days, you end up with $310,000. This is good money, right? But if you went the other way and chose the 2 pennies, then by the end of 30 days, you end up with $10.7 million. This is a great, tidy sum of money. Did you miss out? What influenced your decision? Is it because you've seen the math before, or it's basically because of the way you think? Now, why is it easy for us to go in for $10,000? Because as humans, our brain is wired to think incrementally. And for $10,000, it's easy for you to say that, okay, I'm going to get $310,000 by the end of 30 days. And so for a long time, companies have built strategies around things like this. We have always said we want to increase growth by 10x. But the problem is when we do that, then we miss out on the effect of change by an order of magnitude. And that is called an exponential change, which is 10 to the power x. Now that we all see that exponential change can get us $10.7 million, all of us will say this is what we want. But it's actually very difficult to do because it takes time. Think of yourself as working with someone in an organization, and you all start and you all build strategies. And that person says, I'm an incremental thinker. They won't say it, but this is how they operate. And you are an exponential thinker. So he or she starts at 10,000 and you start at 2 pennies. Now, 15 days into your strategy implementation, they are at $150,000, but you're sitting at $164. Think of going into a room to your bosses, to your, I don't know, maybe board of directors, to explain to them why you are sticking to this strategy. It's not easy. But if you're able to stick to your guns, then by day 27, you're around the block. Now you have $1.3 million. And just 3 days after, you can hit the $10.7 million. Now, why are we talking about this illustration? We're talking about it because I believe that this illustration applies to technologies that are developing exponentially. You see, like the 2 pennies, those technologies initially start to be very difficult. They are very clunky. Only a few people with master's degree and PhDs can do it. But the problem is that they also create this myth in our minds that even after 50 years, they're still the same way. And one of those technologies is artificial intelligence. See, when AI started, yes, it was difficult. It was difficult. Only a few people could do it. But with time, it's now exploded in price, in accessibility, in performance, and in usefulness. And what is AI by itself? There are so many branches of it, but one of the technologies in AI or that we can talk about or use it to define AI is machine learning. In fact, about 95% of the use cases in industry is around this machine learning. And basically it is applying some techniques, machine learning techniques, to historical data so that you can proactively predict what could happen in the future. And when I say data, I am not only talking about the tabular data that you have, maybe in your data warehouses. Most of us will now think of data warehouses and SQL databases and etc. Yes, those are good data. But you can also think of your Excel sheet, your Excel document, your CSV document. It also includes the video recordings that you have, the images that you come across, the data that are coming from appliances, from equipment, the multivariate and univariate data that you have. All of this are data that you can use in making proactive decisions. And in fact, they follow a very simple pipeline, which is that when you collect this data, you will clean it up. You'll try to transform it in some way, shape, or form based on your knowledge in a particular business domain. And then once you do that, now you apply these machine learning algorithms, which are basically some type of functions and instructions that people have written that you don't have to write. They've been written for you. You just have to know how to use them. And then in order for you to avoid unintended consequences, because you want to be ethical, then the next thing you will do is that you will try to govern it so that at least you will build something that will not be biased. And then you will put them in production. And I'm not talking of just, having fancy PowerPoint presentations or maybe some fancy dashboards. I'm talking of really integrating these into business applications. There could be websites, there could be chatbots, any other applications, CRMs, and so on and so forth. And then you consistently monitor them and then you try to improve them. So it's an iteration, it's a cycle, and you keep going back and forth. Now, this method and the application of these methods to some of the data that we described have been used in solving so many different use cases that there are people who have never written code in their life. And I'm sharing these use cases and I talk about them. They are very complex use cases, but I always use these because these in Alberta have been built by people who have never written code in their lives. One of this is in the accounting sector. Someone is using machine learning to augment the audit function. Auditors take some data, they audit accounts or they audit transactions, but there are a lot of transactions. And so what they will do is they will take a sample of those, right? And then they will try to see what is happening. It takes too much time to do. And then it's also not that efficient because now you are losing out on some of the transactions. And so what somebody decided to do is that they will apply machine learning such that now with the audit data, they will be able to learn and detect anomalies. And then they will flag these anomalies. They will now extract it and put it to a place for the accountants to now spend their time to investigate why these transactions are deviating from the norm. It's faster, it is more efficient. Another use case is in the utility space. We all use electricity, even if we don't work in the utility space. We know that we consume electricity. So one of the things you could do is you could predict energy consumption. And this is very useful for utility companies because knowing energy consumption, now they will be able to plan how much do we generate. In fact, if we want to provide reliable energy to different localities, even if we want to, let's say, I don't want to use the word load shed, but that's what comes to mind. If we want to load shed, how do we do that appropriately and reliably? And by being able to predict your energy consumptions, you will be able to plan and put in place better strategies to do so. One of the common use cases also in telecom is customer churn. In fact, it's not just in telecom. So many different companies that have clients. So predicting the potential customers who are potential flight risk. Which of our customers are going to leave us? If you're able to predict that, then you can reach out to them to try to save them because it costs companies a lot more money to acquire new customers than to retain existing ones. And you can apply the same thing to even product churn. So if you work in a company, let's say you work for a telecommunication company that has cable and also provide internet and then phone. You can predict if some of these customers, they are not going to leave us completely, but they're going to cut the cord for maybe phone. They're going to stop using the phone or they're going to stop using internet and maybe just use cable. then what can you do? Because one thing machine learning can also help you do is that it can also tell you why these people might be taking these decisions. And they all exist in the data that you've collected. And these are use cases that people who have never written code in their lives have built here in Alberta. A very common use case is also product recommendation. We all see this all the time. When you go to Amazon and you buy a product and it says that people like you also purchased that product. People that purchase that product also purchase this other product, then it will recommend it to you. On Netflix, when you're watching Netflix or you're watching a movie on let's say YouTube, then right after watching that movie or listening to a particular kind of music, it will recommend another one because people similar to you did the same thing. This is product recommendation, and you can use it in so many different organizations. And one of the places that this is really being used is in the bank, the financial institutions, or the insurance companies, because sometimes customers do not even know what they qualify for. And so when you build these, you're able to recommend, and the probability of uptake is actually very high, and you help increase the lifetime value of your customers. Now, in the oil and gas industry, another use case that is being built, which is in the computer vision space, basically the video recordings that they have or some of the images, thermal images that have been taken, is predicting or detecting emission. There are a whole lot of poisonous gases in these plants, but it's so hard to detect them when they start leaking. And so from these images, you are able to apply machine learning to detect or to detect some of these poisonous gases that are being emitted into the atmosphere. It helps them to meet their safety standards. And like I said, these have been created by people who have never written any type of code in their life. So if you feel that it's so difficult, or you think that it's so difficult to apply machine learning techniques because you think I have to be a programmer, I have to be, no. This is all changing, and people are using the current technologies to solve problems. And why do I say that? Like I said, AI has become very, very useful. If you look at all those use cases out there, companies are embracing it. Like we also said, we spoke about Facebook, we spoke about YouTube, Netflix. Every day, most of us use maps. Now with COVID, we're at home, but if we have to go to a location we've never been, even if we've been, sometimes we want to know the fastest route. So we use our maps. So it is around us and we use it every day. But for a long time, the complexity in the technologies for building these AI solutions have been also very, very high. They've been very complex. And because they are technologies that are developing exponentially, they've left this myth in our minds that they are still complex. But the truth is that they were complex about 50 years ago, maybe even 20 years ago. But for about 10 years ago till now, a lot of people, including Braintoy, have been asking ourselves these questions that if AI is supposed to make our lives easy and useful, then why can't we use AI to make the development of AI solutions easy? It's a legitimate question. So then we find out how we can make that happen. Because if we can do that, then we would say that we have truly democratized AI. Then we can put AI in the hands of everyone, and everyone can use it to solve meaningful problems. And it's not just Braintoy thinking about that. There are a whole lot of companies that started thinking about this about 10, 15, or 20 years ago. So it is no more complex. It is actually very easy for everyone to use. And I wanted to show you, usually I will not show a demo, but I thought maybe I will show you how you can actually solve a very simple problem. We spoke about customer churn. So let's give ourselves, let's say 15 minutes, and I'm going to solve a customer churn solution with you here. Customer churn is predicting if a customer of ours is going to leave or not. So imagine us having a data, and we've called this customer churn. So this is this data. Now, if I click on this to show you the data, you will see that just like you might have in your Excel document or in your database, you have row numbers, you have customer IDs, surname, credit score, and so on. A whole lot of information about each customer. And then you have a particular column that says this customer is going to stay or they're going to leave. So if it is 0, they're going to stay. If it is 1, they're going to leave, right? And you have this because you have customers who have already left. And so all you do is you create a flag called, exit or exited. So if the person has left, then it's 1. If they're still with us, then it's 0. So you have all of this data. And one of the things that you can do is you can now say, I want to predict which customers are going to leave, which ones are going to stay, so that for future customers, I can say, is this customer going to leave or are they going to stay? So what we will do is that we will explore that data, something that all of you do even in Excel. So you can see the distribution of the data, you can see the mean, the standard deviation, and a whole lot. And I wouldn't want to really go into it. You can even do find some relationships that exist between some of these customers, how they interact with each other by using different types of charts to find out the relationships between the different types of columns. If you are used to pivot tables, you can do the same. It's so easy to actually interact with it. And I'm using this, but this is not the only solution. If you want to clean up the data, there are a whole lot of things that have been built into it that you don't have to write codes to do. You can just click through. But because of our time, I'll just go through it by using something called automated machine learning, AutoML. In about 4 clicks, we're going to create a machine learning model. So what we will do is I'll click here to select my data. So I select this and I say customer churn. So this is my customer churn data. Once I load it, I'll select what I want to predict. So I want an algorithm to learn from all of this, and I want to predict, are they going to stay with me or they're going to leave? So this is called the target, exited. Once I do that, I'll just say autopilot. And then I'm going to give this a name. And maybe I'll call this IMM. So I say start. And what is happening is that it's actually cleaning the data for me. It's doing all the transformations, it's doing all the wrangling, it's applying all the sophisticated machine learning algorithms. Some of you have heard of deep learning, and it's doing all of that, and it's going to create these models, it's going to rank them, it's going to tell me which of these are actually the best, and which of them will give me the best performance that I can look out for. So as you can see, these are the logs of the process happening. And then you can also see here that now it's building these with these algorithms, and then it's ranking them. So I can see that, okay, I can get 85%, accuracy. And now something came up, 86.30%. So maybe I can predict accurately 86% of the time that a customer might leave or a customer might stay, if that makes sense. And this we did in a couple of minutes, and I'll actually walk you through, we still have some time. I'll walk you through really making use of this and creating something like a simple web page that you can call maybe your website, or you can even see how you can integrate it into your a chatbot, a CRM, or any other thing. So now it says complete. So I have all these models, and one of the things I can do is I can just click here, and then it will show me. So I named the model and I called it IMM, right? So you can see this is my IMM, and then these are just added based on the data that I'm using. And these are all the models that have been created. Some of them are really bad, others are really good. They've been ranked on this leaderboard. But I can look at the performance in other charts, and this all depends on your knowledge in evaluating some of these models. It's a matter of just clicking through and then identifying some of the performance metrics. And we're not really going into how to read some of this, but this is an okay model. It's a good model. So we have models. There are so many of them. We choose one that we want to put in production. So let's say we have a company, and what we do is we predict customers who are going to churn for maybe telcos. So I'll just say publish, and this is where we govern the model. You have to be humble. Get someone to review it. So I'm publishing it to myself just for demonstration purposes, but that's not how you do it. You publish it to, you get a peer reviewer, somebody in your organization. And so I select that, and then I'll just say publish. The person will get an email that so-and-so has published a model to you. You can see that has changed. And all I need to do is I go next. When I go next, now I will see that I have this IMM model that was created. This is the version 9 of all the models that we saw in the model container. And I have automated documentations. This is how much space this model is taking on disk. This is how much time it took to compute. This is the accuracy. This is the data, and it's actually interactive. So that person can interact with it. They can see what type of data did this person use. In fact, they can even click to see the original data set, and they can download this data, take it back to the beginning of the process, and also replicate the same thing. These are when the model was created, these are the columns. We usually call them features in machine learning. These are the columns that were used in building the model. A machine learning model will split your data. It will give more of the data to an algorithm to learn from, and then it will give very little of it for an algorithm to evaluate it. It's like teaching kids in a class. You teach them a subject and then you give them a test. Basically, this is what happens. So this is the split, and a whole lot of things that did happen. We can even test the data, but we will not really go into it. But we have a model, we've published it. Now somebody looked at it and they said, hey, this model is good. Let's put it in production. All we do is we accept the model. If it's not good, we will add comments and we say, no, we will not accept this model. But let's say this is good. So for a company, now we are ready to put the model in production. We just click next. So once we click next, we deploy the model. As in order for you to integrate your machine learning model into applications, you have to write something called a microservice or an API, which to most of us, what is it, right? This is something that software engineers develop. But now you don't really have to be a software engineer to do so, because again, we're going to just click and we'll be able to do that. So how do we do it? I'm going to click here called Manage Apps, and we're going to create an app. So let's call this Immigrant Tech, IMM Tech. So we just created a company, and we created an app, and this app we called Immigrant Tech. And what it does is that it predicts customer churn for people, right? So now we have to deploy something. We have to deploy a model. So I can see, I have to look for my immigrant app. Where is it? Oh, there it is. So now I'll just select or swap models. When I do that, I look at the type of model that we built, which was IMM, which is this one here, and we published version 9. So we could have published different versions of this model, and the one that was accepted is what we'll put in production. So I'll say, use this model, I'll say confirm, and then I will say deploy. There are other ways of deploying, but we'll just select microservice and API. Basically, what is happening is, let me use this analogy to explain to you. Imagine having a kitchen where you make a meal. So you go there, you have all your ingredients. Your ingredients in this case are your data. The kitchen that has all the stoves and all the things that you can use to make a meal is the platform that you're looking at. This one is MLOS, but there are a host of them, so many different ones. Once you make a meal in a kitchen, for people to be able to eat it, let's say in a restaurant or at home, you have to put them on a plate and then you will serve it out, right? So the plate on which you will serve a machine learning model out is called the microservice, is the API. So now we have a plate that has been developed. This thing says it is running, IMM Tech is ready, and we all have access to it. So let me look for the app again. Where is it? I can't find it. Oh, there it is. So it's ready, it is running. And how can we actually make use of this? There are two ways. I'm just going to download this as an app. So automatically we can download an HTML web page. So maybe I'll call this IMM, I don't know, tech churn. Maybe this is the name of our website. So now that I have this, I'll just double click to open it. And I hope you can still see my screen, right? So imagine this is a website we've developed, and usually people will provide us information, just like in our data set. Remember, we had credit score, geography, all of that, right? So when somebody provides this information, we want to be able to know, is this person going to leave or are they going to stay with us? Now, just as we all have usernames and passwords, it's similar. Now the plate that we created, or the microservice, we have to give it access, right? So we will create something called an API key and an access token. So to do that, we'll come back into our technology here. And in this technology, we are going to now generate that username and password that will give the access for us to talk to the model that we just developed. And so what we will do is we will go to manage apps for this app. And we want to generate what we call the API key and the access token. So I'm looking for our IMM tag, and then we'll go to API. Now we've generated an API without writing a single code. We are not even software engineers. So I'm going to give this an ID, and maybe this is talking to our website, right? Maybe we also could have a chatbot or something. So we'll just give this some type of key. I always compare this to an email transfer. And then you say generate. So it's generated this for me. And this is all the information that anybody, if you work with software engineers and they want to talk to an API, they'll always need what is called access token and an API key, or a private key and a secret key. So now let's copy this, and then we'll paste it in our new website here, which predicts which customers are going to churn. And then we'll copy the other one here. And then we'll also paste that here. So assuming somebody comes and their name is Hale, which it doesn't really, but their credit score is 608, they come from Spain, they're female, they're around 41 years old, and so on. Then when we predict, we say, are they going to leave or not? So we put the information, but we have to activate the key. So something I forgot to do. So let's just do this, and let me share it with myself, which is a very simple way of activating that key. And I share it. And so now when I come back here and I hit that, see, I get a response, right? It says this person is not going to churn, 0, they're going to stay with you. And by the way, this is what is contributing to making this decision. All of this estimated salary, do they have a credit card, does not really contribute, so they are red. But the ones that really contribute to making the decision that this person, Hill, is going to stay with us is how long they've stayed with us, what is their age, their gender, and which country they come from. And by the way, I am 74% sure that this person is going to stay with me. And I'm only 26% sure or confident that they're going to leave, right? You can make changes to some of these parameters here. Maybe we change this to 26 if we have something like that and then maybe the number of products, and then see, still such a person is going to stay. Now you can see how quickly we have been able to build a model, and I just want to move on. Now, what do somebody in an organization that has built a model like this, and all the people that have applied machine learning, what do they all have in common? They have what I call the triple benefit of AI in common, which is they reduce cost, they help improve efficiencies, and the result is that they are able to increase profitability, or they can increase revenue for an organization. So if you want to help an organization, then this is what you have to do. Now, because this is immigrant tech, I do not know how the job market for us here in Canada is for all of us. But one of the things we could do is that we could learn from this picture, I thought. This is a picture of a man called JR. Now, JR is a photographer. He's a very famous guy now, but he used to take pictures of women and he will blow them up and put them on billboards, and he'll put them on runways and etc. But what happened is that some people loved his work, but some countries also really hated his work. And so the countries that hated his work put out a warrant for his arrest. But at the same time, JR got commissioned to do a self-portrait. And I got this from Amy Herman, and she has a YouTube video and she talks about this. So now JR has a problem. And the problem is, if he takes a picture, they will know who he is and he's going to be arrested. But if he doesn't take it, he also miss out on having a very good project that could propel his career. So he did what you can see on that slide, which is he took a picture of himself through a woman's eye, called self-portrait through a woman's eye. So he solved his problem creatively. Now JR has no warrants. He's a famous guy. He had a problem and he solved it creatively. What's the point? The point is that AI is here and it works. We do not have to run away or shy away from it. The jobs of tomorrow belongs to people who can solve problems creatively. And if you are new in a country, if we are immigrants and we really want to fit in, what companies will be looking out from us is our ability to help them either grow by increasing profitability, reducing cost, or improving some type of efficiency. And one of the ways we can do that is by thinking exponentially, embracing emerging technologies like machine learning and artificial intelligence so that we can spot opportunities for growth and we will help them to solve problems creatively. There is a quote from Elon Musk where he says, if your competitor is rushing to build AI and you don't, it will crash you. This is true for companies, but on an individual level, I also think that if the people I am applying for jobs with are thinking exponentially and embracing machine learning and AI in solving meaningful problems, and I am not, then they'll crash me in an interview. They'll always get the jobs. They'll always get the promotions. So if I really want to be able to grow, if we all really want to be able to grow, whether as entrepreneurs or as skilled professionals, then let's work hard. Let's change our mindset. Let's have a growth mindset as opposed to having a fixed mindset. And let's work towards learning and embracing emerging technologies like machine learning and AI, and then using them in solving problems, meaningful problems creatively. Thank you. Any questions?
Thank you so much, Kwame. I have a question here from Nia. So she's asking, so can you integrate the machine learning model you built with another app through the APIs?
Yes. So that API, that website I downloaded was a standalone application. And so if you have, let's say, a chatbot or you have a CRM or anything which is hosted, all I need to give you is the URL, the access token, and then the API key, and you'll be able to talk to that model. So yes, you can integrate it into any type of application anywhere.
Yeah. And a recurring question I know from someone like me, for example, with no technical background is, it's the intimidation. How much of actually technical knowledge or background on Python and any of that should we know to actually have the guts to put on our hands on something like this?
Yeah, so that is actually what I'm trying to address, is that, you see, in your question, you quickly jump to how much of Python should I know? So, you know, in our mind, we think, oh, I need to be a programmer to be able to really do this, right? But that's not the case. The world is moving towards what is called a no-code and low-code environment. There are a lot of jobs for citizen data scientists. To be able to really scale data science, there's always more jobs for data scientists than people can fill them. So to be able to scale, we have to develop some of these platforms. So you don't really need to be a programmer, but what you need to try to learn is the principles of machine learning and how I could apply it. For instance, we said accuracy of 86.86%, and then there were some other charts. What do those charts mean? How do I read them, right? How do I avoid biases, you know, and avoid unintended consequences? Those type of things. If you can learn these principles and you know how to use the mouse, you should be able to build or apply machine learning and AI in solving meaningful problems.
That's exciting. Thank you for that. And there is a question about what about prior knowledge to statistics?
So we actually are running a course with SATE, and we have people who are in communications, people, religion, music. We've had biochemists, of course. Biochemists is heavy on statistics, but some of these people just knew how to use spreadsheet, right? So they know what it means to add things to add two things together, subtract two things together. But you are intelligent enough. You are all skilled professionals. So some of these analysis, and you already know how to do analysis and to gain insights from data. And if you take a really good course, which is applied machine learning or applied AI, that is not a prerequisite. It is good. You have to be intelligent. Yes, I'm not saying, but the knowledge that you have, being able to at least work with spreadsheets and making some deductions from this is enough for you to be able to learn and apply these skills in solving problems.
Yeah, and this, I think, targets the second question about where can one learn such principles. So if you can highlight a bit more, Kwame, about the boot camp, that would be great as well.
Yeah, so SAID has the applied AI bootcamp. The third cohort is actually starting in September. So I don't know if it's still open. You can join. But SAID is one place that you can join. And I like that because it's applied and it's also one-on-one, but it's slightly different from the ones you find online, right? So that's a place to look at. I think U of C also has something like that. I don't know. I think they were talking about it. I don't know if they've rolled it out, but they said applied machine learning is very useful. If you go online too, there are a ton of resources. Now, AI, machine learning, these are the buzzwords. So you just have to Google and you will find a ton of resources there. There's Coursera. I don't know if you've heard of it. Coursera has a whole lot of these courses. Udemy has a whole lot of these courses. And if you take them, they'll be very helpful. The only difference, and in fact, the recommendation I'll make is that taking those courses are good online, but mostly it's difficult for you to apply it because there are a whole lot of information. It's difficult to sift, the important ones from the chaff. So we've had people join some of those applied machine learning courses we're doing with SAID, and they've already taken 2 or 3 data science courses in Coursera. But the reason they join is that they don't know how to apply them. But at least they have the foundation and they have the knowledge. So if you want to get into it, yes, start from there. Joining a webinar like this is good. Join some of those webinars where people try to break the black box open and demystify. Join those, read some stuff, try to apply them, and gradually you'll be able to build upon it. But if you really want to get hands-on, then I'll recommend the SAID bootcamp.
Perfect. So there's a question, as a cybersecurity analyst, where does AI come into play?
Yeah, I think somebody asked me this question maybe 2 weeks ago. I don't know if it's the same person. Anyway, so
it's Chris. It's back to you, Chris.
I'm not the one that asked you though.
Okay. All right. So cybersecurity, I think it's also a very hot topic these days. I think cybersecurity and AI are really important right now. Now, all I would say is that in cybersecurity, what you are trying to do is, and there are so many different aspects of it, and I'm not going to speak as if I am an expert in cybersecurity, but what you are trying to do is to prevent, some actions from happening, actions that could hurt an organization, as an example. You want to prevent them from happening. So AI can help you to be proactive in doing that. If you have historical data, then you could apply machine learning and AI to it so that you can proactively see what could happen in future. The slight problem I see with cybersecurity is that there is not enough data out there for you to begin to work with. But you also don't need a lot of data to start applying machine learning. So the little that you have, if you work in cybersecurity, you have the data. The only thing is that they've not started exposing it to the public. So for me, because I am not in cybersecurity, it's hard for me to get my hands on, right? But if you work in that space, you definitely have access to that data. So begin to think of ways in which you can be proactive, how you can get ahead of the game, how you can get ahead of a problem before it occurs. And this is where machine learning could help you. I don't know if that makes sense.
Thank you, Kwame, for that. Another question, realistically, how difficult is it to get a job in the industry?
So I will use the bootcamp results as an example. In fact, we did, Mia, you said you were there, so you might have heard somebody ask this question and the answer that was given. The first cohort of the SAID bootcamp had, I think, about 20-something, 23 or 24, right? And about 17 of them have jobs now working in data. And some of them came with no knowledge in machine learning at all. There are some of them working in data or AI departments. Some of them are Scrum Masters, some are product managers, some are citizen data scientists, some are model governors. There are a host of them. And there are 4 or 5 of them who just say they are not looking for work. They want to be entrepreneurs. So they have created a company together. In fact, Braintoy is supporting them. And now it's called Envision ML. You might hear them come out, recently, very soon. And they are also solving problems. The recent cohort had, I think, 13 people. And before the cohort ended, 4 of them had jobs already. In fact, one of them was a real estate agent. And he said, I've always worked in construction. I've always worked in real estate, and I want to pivot. And I don't have any skill. I've never written a code in my life, all of those things. But he took the course and he stuck with it, and he was learning. And he had a conversation with me, and he said, when I went to the interview, he spoke about the interview to a point, and he said, and then they asked me a question about how I use machine learning in solving one particular problem. And he said, that is why I murdered them. This was the exact words he used, just from attending, the boot camp. And now he's working. And some of them have reached out asking for references and all of this. And we just finished that cohort, I think, about 3 weeks ago. So if 4 have gotten jobs already and some are interviewing, you can just see. So there are a whole lot of jobs. This is hot right now in Alberta. Canada was late. Well, Alberta was late in adopting this technology, but now they've realized that it's important. And so there are a lot of roles out there for people in this space.
Right. And I have to highlight as well from personal experience that as much as this applied bootcamp is valuable in knowledge and the skills that adds to you, networking that goes through this application itself helps a lot to push you forward. Yeah. Another question is, are there meetup groups specializing in AI or machine learning?
I think they are. Actually, I have not been to any of those groups. There is Drew Gilson, who runs I think there's an AI meetup here in Calgary. His company just recently got bought by Google. And so I don't know if he's still running it again or he's still the company that he worked for, but he's still working. We have the Calgary Data Science Group, which I actually created, that has about 250 members, but I passed it on to someone, and I have been hands-off for a while, so I don't know, but that's a good question. Actually, I need to get back in there and see what's happening there, but you'll find the Calgary Data Science Group on LinkedIn. I think there are a few. The GDG, the Google Cloud Development YYC, even though they focus on development, sometimes also do a little bit about machine learning and AI. So it's also a good place to look at. But I think if you start looking on LinkedIn and probably Googling, you will find some meetups, but there are definitely AI meetups here, I know.
Yeah, if I could quickly jump in there. So there are I know of 2 meetup groups, Civic Tech YYC and Data for Good, where they actually do a lot of data projects. So if you're learning this, maybe you're going through a boot camp or you're self-learning and you're looking for some project to try your hands on. So they are always having projects for people to practice what they're learning. And there are projects that help the city or the province in one way or the other. So yeah. And we will be having a joint event with Civic Tech YYC in November. So. And if I could be the one to ask the dumb question. So everything you described, you have to have that data before you can even start to extract information from it. So if you don't have a data repository and you want to solve problems, is there a way to get it externally? Are there ways to work around that?
Yeah, first you need data to be able to do anything machine learning. So if you don't have data, there are sites like Kaggle.com. I don't know if you've heard of it. So Kaggle, Kaggle.com. And they have a whole lot of data with a whole lot of examples and use cases that people have donated. In fact, Netflix even donated some data because it's also a competition where companies come and say, hey, we have this problem. We want to see who can solve it. And so they'll give you the data and you can use it. There are a whole lot of data there. There's also a website, UCI website, which is a university. And they also have a lot of open data. If you also just Google open data, you'll find a whole lot of resources
Can you spell that? Open?
Open, just open, yeah, to open a door.
Open data, okay.
Yeah, you'll find a whole lot of resources and you will be able to play with it.
There are two more questions here. What about volunteer opportunities in machine learning?
Yeah.
Is that an option? Yeah.
Yeah, I think I do not know any organization that says, hey, come in here. I know there are internships, like even Braintoy, we do some internship. We do have some internship opportunities available at times. And so those are what I would call, but I haven't seen anything like, volunteer opportunities, honestly. But I would say if you are looking for some of those, then maybe look for internships available. Recently, there is a Women in Tech webinar that we were invited to, and in fact, there are 2 people that will be joining Braintoy from that as interns. So if you join some of those things, it might help.
Yeah, you can also check out Cybera, yeah. So they are a nonprofit that's focused on data science and machine learning in Alberta. And recently they launched a program for data fellows, like a fellowship program that takes on people and train them. And yeah, so there are resources in Alberta, you just have to look.
Yeah. So another question about the bootcamp, actually, is it available in an online only format?
The first 2 were purely online, but this one that is starting, they want to do it in person. So I actually went to the Odd Fellows building, which is where it's happening downtown today, to just see the setup. So this is in person if you want to join this one. I do not know what SAIT would do after this one.
Another question, if the data in your organization is not clean, how do you go about implementing machine learning? Do you clean up the data first or you start gathering data from scratch?
I really like this question and we get it a lot. One, if you want to wait till you will have completely clean data, you will never start. That's the thing. There's always noise in data. And I am not saying just use really garbage data, right? I am not saying that. But you will find that if you have a lot of data in your organization, you definitely have some of it that is really good. So you have a lot of data and you brainstorm and you realize that, okay, we have 10 ideas. And out of these 10 ideas, 1 of it or 2 of them have really good data or solid data. And maybe they're just sitting in a CSV document, but this is data you can trust. We usually call them the ground truth. You can use this to begin to solve problems. Another thing is that if there are loopholes in the data, some of the stuff are missing. You have subject matter experts who have worked with this data for a long time. So what you could do is to start with, you can talk to some of these subject matter experts and use their knowledge and experience to fill them in, right? And then you also listen to them to give you some of the rules in which you can use to clean them up. And some of these things you can just do in Excel. And then you have a certain amount of data. People always think you need to have a huge amount of data. No, a couple of records. We've built real life solutions with 200 images, as an example, for computer vision. We've built models, real life solutions with 10,000, with 1,000 records, 10,000 records. You don't need 1 million records to be able to do so. So if you have a certain amount of data that is good, take that section, start with it. Because as you build a model and you put it in production, as people begin to use it, you will start collecting more data and then you can use it to improve it. So if you have nothing, something is better than nothing. So start with what you have and then look at how you can collect more data to improve it, if that makes sense.
And I want to reflect on that as well. While you were doing the slide about importing that data and the peer review, I know peer review is really good in like trying to prevent errors, but I feel like there is always going to be a chance of error in data. How can we minimize that?
Yeah, so I think your question is in twofold. For errors in data, one of the things you need is just to talk to the subject matter experts. So one of the big problems with data scientists or data science is that they focus on the science, the data science, but they forget about stakeholders and businesses. And that's one of the things that SAFE tried to teach in the bootcamp with essential skills. So talk to business folks, the project sponsors. They know what good data is for their business domain. So if there are errors, they will help you to fix them or to correct them. The second thing is that in any of these platforms, like the one I showed you, there are techniques, there are algorithms built in them that you can just select. For instance, if you have a record of, let's say, ages, and let's say there are 10 records, 2 of the ages are missing. You can replace those 2 ages with, let's say, the average as an example, or you can replace them with a median, or you can replace them, it's called imputation, right? It's just a matter of deciding that this is what I want to do. And then I'll say, okay, I want to replace it with the average. So I select age, I select average, and I hit a button and it does it for me, right? So this is another way in which you can correct them. Now, this is with the data part. The errors in relation to models. And the way you can correct them is understanding the proper ways in which you can apply the machine learning techniques. And this is why I said acquiring that knowledge is very important. Because sometimes you might even have data and you have a lot of data. Let me give you the example. I don't know if you heard it. Amazon built a model that was biased towards women in their recruiting system for 5 years. Did any of you hear that story? You didn't? Yeah, so about 3, 4, 5 years ago, it came out that Amazon had built a model, and the model, their recruitment system has been biased towards women for over 5 years. Now, the reason is that they built that model collecting a lot of resumes from men. So when that machine learning learned from it, now it became biased. And so it was always favoring men over women. And then they caught it, right? This is a big organization. And they have amazing, they have skilled people. I don't know why that happened, but maybe if they were humble enough to maybe just get a peer reviewer, they were humble enough to just get people to take a look at the solution before they put it in production. Maybe they could have avoided that, right? So these are some of the ways, understanding the principles, at least being humble to get someone to review it, maybe just going over your own work before you put it in production. Some of these things could help you also avoid some of those unintended consequences.
Mm-hmm. This is like a huge topic of its own, maybe talking about ethical AI, but I do know there's the tendency to introduce bias into your data, into your algorithm, because if it's learning from experience and the experience itself is already warped, how do you prevent transferring that, like continuing an error, carrying it forward? So in your processes, what steps do you take particularly to take out the bias, or to just check that what you're building is not, I read something where somebody is Filipino. So they said the language is gender neutral. But then, so if you type in English, if you do a Google translation, and it said, if you typed it in Filipino and just said, he or she is cooking, English would definitely translate it to she is cooking. But if you type he or she's driving, it's going to translate it to he is driving, right? So how do you work around that? Some of this is just a reflection of what is. It's just because most likely maybe it is he that drives, it is she that cooks. But to correct this, how do you introduce that into your model?
So let me give you a very simple, maybe scenario example. Think of fraud, right? And legitimate transactions. We all do banking all the time. And most of the transactions you do are legitimate. Once in a while, there is a fraudulent transaction. So if we collect data about all of us and we have 1,000 records, there is a high probability that we might get 900 legitimate transactions and only 10 fraudulent transactions. This in machine learning is called imbalanced data. because you have 90% of one category and just 10% of another category. Does that make sense?
Mm-hmm.
Yeah. So just like your scenario there, Philip, maybe they had like 90% of men, and it was always men driving, right? And so it learns this. So one of the things you could do, and there are so many different techniques, but one of the simplest things you could do is that imagine if I take the 10 fraudulent transactions that I have, okay, and then instead of feeding all the 1,000 data to an algorithm, I take only 10 non-fraudulent transactions, or maybe 15 non-fraudulent transactions, and pair it with a 10. Now I have 25 records of 10 fraudulent, 15 non-fraudulent. Now I have removed that imbalanced data to balanced data. The algorithm is going to learn from both categories, similarly from both categories, because we have similar representations, if that makes sense, right?
Is
So
there
now,
a process around that, or is it just subjective?
this is actually a very simple thing. This is sampling. So I'm just taking a sample of my 900 transactions. Maybe I'm just taking 10% of it or less, right? And then I'm pairing it. Now there is a risk there because I might be missing some of the behaviors that is in the 900. But instead of using all the 900, then I can take so many different 10 transactions. So I take 10 transactions at different times, and then pair each of those with my 10 fraudulent transactions. And I build so many different models, and I can evaluate them and see which one is really doing better, right? That's one very easy way. The Amazon example as an example, instead of using maybe 900 resumes from men and only 10 resumes from women, they could have taken 10, 10 or 15, 10 and built the model. So now when it learns, it's more or less 50-50. So when a decision comes, it's not going to be biased towards one particular category, right? So this is a very simple scenario and an example. Now, it could be very complex, and I guess this is not a forum for that, but this is one of the easiest things you can think of in avoiding some of these biases. Yeah.
Wow, we are past
We're past
time
time.
already. Yeah.
Yeah. Thank you everyone for your questions. Kwame, personally, thank you so much. This was so interesting and exciting. And I think we can even go to another hour just like to cover all the questions that we have in our minds. But yeah, we don't want to take much of your time. Thank you for that.
Thank you. It's a pleasure thank you for having me, and it's a pleasure being here.
Yeah, and thank you so much, Mike, for co-hosting tonight. I appreciate that. Yeah, so if you don't mind, if you can leave if you want to be on our mailing list, please leave your email address in the chat if you're comfortable, so that you can get information from us. And with that, if nobody has any other question, I think we'll call it a night. Thank you so much, Kwame.
Have a good night. Thank you.
Thank you so much, Kwame. Thank you.
I'll leave the room open for anyone that wants to hang out for a while.
Thank you so much.
Thank you,
that was a great
Nancy.
session. Yeah, definitely great session.